Good morning, Scott. So your parts are here, and as you can see, they have just the slightest burr. I think I could remove that burr just with the DM1100 crossbelt machine, which you see over here. Very simple, $55,000 machine. But because you have some weld splash on it, it is probably better to first run it through a belt sander, and we have those two machines combined. A similar combined machine you see here, this is also same company, NS, and this is why I would propose it. It has a 9-inch large contact roller for the belt sanding unit. In this machine it's then combined with a similar roller like you saw from Time Saver, but I think that is a more expensive and more complicated solution than what you really need for what you are trying to achieve. Plus we can go 44-inch with if we combine it with a belt sander for less money. But what's important is that this contact roller is 9 inches. It's rather large. I would pick it soft so that it is for deburring more than for surface grinding. At the same time, we don't want to roll over the edges, as you said. I put a very fine grit on it because we don't have a lot of material to remove. I put a 180 grit on it. I can't see that here with the camera. So we're first going to run the part through here at 20 feet per minute. And then we are going to run it through the crossbelt machine, which you see over here. The crossbelt machine is very simple. It has these blocks, Scotch-Brite and abrasive alternating, and it goes oblong over the part. This is a high friction belt. It can hold a very, very small part down to 2 by 2. Actually, if you could really clean it up, it could hold smaller. And that will take the secondary burr off from the belt sanding process. And what we would quote to you is a machine that is a combination of this belt and the 9-inch heavy-duty contact roller from NS. So, in order to get this going, and currently the top speed on this machine is 10 feet per minute, but we have controls here where I can control my crossbelt speed. Right now here, at about half speed. So we are going to run at half speed, and at the same time your conveyor belt here is running at 10 feet per minute. And again, we can configure a machine for you that runs 20 feet per minute. On the other machine I can also simulate 30 feet per minute, and we can try that and further reduce the crossbelt speed here. So we will take one of these parts, and this is significant because see, you have this splash especially around the small hole, and run it through the NS machine. For that, we turn the belt on, turn the conveyor on, there it is. You have this set the thickness to 2.6 millimeter, which is approximately your material. And we just, I don't know if you have a preference in terms of the grain. I would prefer always to run parts over the longest diagonal, because then you get the best effect. So I'm going to do that. You can see where it's about what the grain direction was on the part. At 20 feet per minute, it's going to come out reasonably quick. This is the very first part that I run. I haven't done any setup or test runs, and we need to now see whether we have removed that rust. When we look at this, the outside edges are very good, right? But I need to set it a little bit harder so that it hits on this hole. The way we do that is regulate it here on this side, we come down, that could be really one of the speed. And also, of course, if you would grind slow, go a little bit better. So we'll repeat that process and see if you can hit it a little bit harder. There we go. And of course, this is not a very good test right now because it's been grinding a second time. I don't know if you noticed the noise in the background. It's grinding a little bit harder. The other thing that we could also do is we could go to a little bit coarser grit, which I really don't want to do because I think it is going to do bad things with your surface for sealing. See now, by hitting it a little bit harder, this hole is clean. And we'll try that on a new part in a minute. So, it has run through the belt blender like this, as you can see on the grain. So we're going to hold it perpendicular here, and we are going to run it through the crossbow. At that point, we are going to get a slight crosshatch in the part, and you can see a little bit debris around it, very lightly, and a knot. I wouldn't call this a rounded edge, but it is so that it can't cut itself anymore. Like I say, in all this we can determine by speed whether you want to have a little bit more or a little bit less. Okay? So this would be the equivalent, and we'll write that on here right now, of 20, sorry, not in, feet per minute, P180 plus cross belt. Okay, now we will try that exactly with the new piece again. We'll take the next one that has a little bit of dross. You can pick the part with the most dross for the first one for the setup. Well, we'll run one like this. This has quite a bit of dross on it also. So again, we will run lengthwise. We'll proceed at 20 feet per minute. There we are with that part. That is good and clean. And then we run through the edge mount part. Actually, I put on here, that was the first piece to pass, and that was one pass, part number 2 feet per minute. Like I say, I would say these edges actually came out a little bit. We set the cross belt a little bit harder, so I write plus here, then I'll write the medium pressure here. Right? I'm actually now, for test purposes, I'm going to bring this down to about 15 feet per minute. And according to that, we are going to bring this speed up. Where it also represents 50 feet, just so that you can see what that is, and run apart. way so that we have the same format. There we go. Now you see we have a little bit more on the edge, maybe more than you want, I'm not sure. And we go to the intro. Now that we are going slower, I'm going to go lighter again. I won't write that in the future, it was just the first part. So that's 15 feet per minute plus cross melt at a medium pressure. So now, if we go slower, of course we should also go faster again. So this here resembles about 30 feet. Now for 30 feet a minute, I will have to go here. Sorry. For 30 feet per minute, I will have to go here very slow. Check my inverter settings real quick. A little bit less still. I need to be like this. But at the same time, I will go in a little bit harder. Everything is clean, everything is good and stackable, I don't have any excess, so that should be very good. We can try to go even faster. At some point you need to be careful that you clean up spots like these. So now I would do about 35 feet per minute. The machine doesn't quite run 40. So this is the maximum speed this machine can run. So that's about 35. And actually, you see, the hole is clean, but it has something hanging off to the inside. I'm not going to touch that to see if this comes off. Yeah, and we go here, and at the same time we go still a little bit slower in order to make up for that 10% more belt speed on the inside. So this would be the equivalent of 35 feet a minute. And remember, you can always get a little bit more or less edge rounding simply by setting the brush is harder or softer. And as you can see, we did not remove this little piece here on the inside because it is really on there. I'm just gonna leave it there for now. So 35 feet per minute. like the 30 the best, so I'll make one more part like this. So we go here, back, that weld speed. So here, back. So yeah. And I'm going to run this last part that has some splatter on it, as you can see here. Like I said, this is with the 180 grit. You could have tried other grit, but I think the finer grit is more what you are looking for, because ultimately it will remove less surface and will roll the edges. Here you go. All the splatter came off. Right? So of course this afterwards will automatically happen all in one machine, as one process in sequence, and I will attach for you a video of that also, so that you can see a combination machine, what that looks like. That concludes our test for today. So that's another 30 feet per minute plus cross weld. I think that is the best process for your part. We also have a machine over here that would combine a deburring drum. That is what your compatriots at O'Neill have for deslagging. It would combine a deburring drum that you see in here, not a belt, for deburring, and also cross belt behind it. But that machine, as the machine that combines the rotor with the white belt sander, is only available in 26-inch width at this point in time, which would be fine for the parts that you are running, but you said you wanted to run some larger sheets also, so you prefer to have the 44-inch, which gives you more flexibility. Thank you very much. I appreciate you sending the parts overnight. We will overnight them back to you.